Hello everyone. In this video we are going to look at how we can use hypothesis testing for two sample proportions and how we can do that with our sheet in Excel. Okay, so we've built this one here. Let's look at our scenario. So it says Jet is an avid watcher of tennis competitions. She wants to compare the proportion of tennis players that hit a one-handed backhand comparing from June 2019 to May 1999. Jet suspects that on average, June 2019 has a different proportion of players using a one-handed backhand than that of May of 1999. She wishes to test at the significance level of 4%. So she randomly selected professional tennis players from each of the years and recorded their backhand type. Here's the data that she collected. All right, so very first thing, let's grab our data, let's copy it, and let's paste it into our document. So we'll do paste special. We will grab this text option and click OK, and we see our data here. Okay, so one of the first things that we should probably do, let's kind of scroll down, and in our hypothesis testing it says set June 1999 as group 1 and June 2019 as group 1 and May 1999 as group 2. So in here, I'm just going to put an equal sign and I'm going to click on the June 2019 for my first one. And for the second one, I'm going to say equals May 1999 for the next one. All right, it's important that these are identical to what they are in your data. That's why I did the equal sign and clicked on them. It helps keep things organized. Okay, the baseline assumption when we're doing this two sample proportions is typically that they are the same. So we'll put in 0. But we think that it's just different. We think that maybe, the sport of tennis has changed over the years. So we're going to put a not equal sign. Our alpha level that we were told to do was 4%. And the trait of interest that we are looking at is equal to the one-handed backhands. And we'll hit enter there. Okay, we should probably just do analyzing the data, and we need to look at our descriptives really quick. So this is how you do it with raw data. If you only have the summary statistics data, though, you can put in the observations and the sample sizes for your individual categories, and then it will calculate it like that as well. So I'm just going to go ahead and click Analyze Our Raw Data, and it got that we had 48 people in 2019 doing a one-handed backhand and 108 in 1999 doing a one-handed backhand. We see the sample sizes pretty close to the same of each one. Now, one thing that we needed to make sure is that for both of these groups, there's at least 15 people who said yes and 15 said no to doing a one-handed backhand. So we have a 48 out of the 320. So both the yeses and nos are good here. And the 108 out of 291, we have at least 15 of people in 1999 saying that they did and didn't do a one-handed backhand. Okay, cool. So when we go down and we look at our preliminary questions, the first thing that we can say is that the type of data that we are dealing with is categorical. Notice over here, there's not really any numbers. We've got a grouping category and then categorical data that we're wanting to analyze. The grouping variable is going to be our professional tennis players, and the response variable of interest is the backhand type. So the population of interest here is going to be professional tennis players from June 2019 and May 1999. Those are the groups that we are comparing. And the parameter of interest is the true proportion of backhand type. We're looking at those two, and then we're taking the difference between them. And the method that we should use is going to be a two-sample test for a difference in proportions. Now, the distribution that we should be using here is going to be a z-test. It's still a z-test, and you can go back and look at the flow chart to get the exact equations if you're interested in those. And is our sample size sufficiently large? And yes, there are sufficient successes and failures in both groups. So setting up our null in our alternative, we have already done this. We set it equal to 0, and we set it not equal to 0. Alpha was 0.04. Now, here we have collecting our data and our test statistics. So the first one asks for like P1 and P2. So those are our sample proportions. So we have like 15, almost 16% in the first one, and we have like 37% in the second one. And we will say that our Z, we have a couple options here. We can do this using chi-squared, but that's using an alternative method. But we get this negative 5.868, which is exactly what we have here. We have a p-value of being really small. In our Excel sheet, it only gives it to 4 decimal places. Here we've got a ton. You only have to be accurate to 4. And the p-value is going to be less than our alpha. And when we run our confidence interval, we get this negative 0.28 all the way up to negative 0.13. Okay, so we need to be able to talk about this. We are going to be rejecting the null hypothesis. So when we do this, there's a bunch of options in here, and I'm not going to go through why each of these are wrong or each of them are right, but you do know that there are some things that we need to talk about. We are talking about how we have sufficient evidence to reject this, the null hypothesis and claim the alternative in this scenario. So I'll let you go through, and you can go through and read these and see which ones of them are correct. These ones down here that are being talked like here with the chi-squared values. Those are if you are doing it with the chi-squared testing, and that is an alternative good way to do this. But if you notice that the p-values match up and our alphas match up with what we have done over here. Okay, and we can say that there is sufficient evidence to reject the claim that the true proportion of professional tennis players to the one-handed backhand for June 2019 compared to May of 1999 are the same, and conclude that the true proportion of professional tennis players to the one-handed backhand for June 2019 is in fact not equal to that of May 1999. Okay, so since we rejected, we now need to go and give us a confidence interval, and we will say that we are 96% confident that the difference of the true proportion of one-handed backhand players for professional tennis players for June as compared to May is somewhere between negative 0.28 and 0.14, rounded from here, with June 2019 being less than that of May 1999. So it's less by somewhere between like 28 percentage points, but by like 13 percentage points to 28 percentage points is the difference there. And then when you upload your work, you can just copy your Excel file and paste it in so I can kind of see what you're doing. And that is how you do a 2-sample hypothesis testing when you're dealing with raw data. The only thing that changes if you're doing with not raw data is you come in here, and in the green cells, you type in the summary statistics, and you can calculate it like that too. So that's how you go through and you do your 2-sample testings of proportions.